Welcome to this explainer. Today, we're diving straight past those viral, carefully choreographed robot videos flooding your feeds. Instead, we're going to uncover the deliberate, massive industrial machinery that's actually driving China's humanoid boom. We're looking right at the policy engine trying to turn science fiction into an everyday factory reality.
You know the videos I'm talking about, the backflipping, dancing robots that make it look like the future is literally already here. But the real question we need to unpack today is this. Does this massive surge in humanoid development represent practical, near-term deployment on actual factory floors, or is it just a huge wave of investment hype? Well, to figure that out, we first have to understand what makes these specific machines so different.
And it really all comes down to grasping the concept of embodied AI. Unlike the digital AI we use every day to, say, write an email or generate an image, embodied AI takes intelligence completely out of the digital realm. It forces a physical machine to recognize an object in 3D space, plan a safe movement, keep its physical balance, and then actually act in the messy, chaotic real world.
There's a massive divide here. Digital AI processes information, right? Text and images. But embodied AI, it has to control motors, joints, and physical balance. This is exactly why a robot can have an incredible digital AI, meaning it perfectly understands what you're asking it to do, but still completely fail to physically pick up an unfamiliar package. Simply put, if its embodied AI isn't mature, it really doesn't matter how smart its digital brain is.
All right, Section 1. The policy engine driving the robot boom.
Beijing's strategy here has been moving incredibly fast. They progressed from broad innovation guidelines in late 2023 directly into naming humanoids as priority products, embedding them in the National Government Work Report by 2025. And now, they're aiming for real-world validation programs by June 2026. Guys, this isn't some passive market evolution. It's an aggressive, top-down mandate to build a completely new industry at breakneck speed.
And the sheer financial scale of this push? It is staggering. $20 billion. That's the amount Chinese authorities pumped into the robotics sector over just a single year, pulling from municipal funds, subsidies, and workspace programs. This absolute flood of capital is designed to rapidly accelerate development and push companies to scale up before the market even fully exists.
So where is all that money going? Check out this massive jump in state procurement. It went from just 4.7 million yuan in 2023 to a jaw-dropping 214 million yuan in 2024. Why? Well, early humanoids are incredibly expensive and, frankly, largely unproven. So government agencies and state-owned enterprises are acting as guaranteed early customers. They're basically stepping in to absorb the commercial risk for these tech companies, which is causing state procurement to just skyrocket.
Moving on to Section 2, China's ecosystem advantage and its massive manufacturing base.
You see, China isn't starting from scratch in the robots game. Not even close. They already hold an operational stock of roughly 2 million conventional industrial robots. Just to put that into perspective for a second, that's about 4.5 times Japan's total operational stock. They already have the factories, the highly trained technicians, and the industrial customers who know exactly how to integrate automation. And policy is strategically leveraging overlapping supply chains. Just think about what actually goes into an electric vehicle. Electric motors, batteries, sensors, vehicle control systems. Sound familiar? Those are the exact same components needed for a humanoid robot. This means humanoid developers can directly reuse the engineering talent, the established suppliers, and the mega factories already built by China's massive EV industry. A perfect example of this overlap is XPeng. They're a major electric vehicle company, but they're expanding directly into what they call physical AI. By leveraging their existing EV supply chain, they're pushing to mass-produce their iron humanoid by the end of 2026 for commercial deliveries. It's literally a direct pivot from 4 wheels to 2 legs, using the exact same technological backbone. Now, you might be wondering, why this massive, rushed state push? Ultimately, it comes down to demographics. By the end of 2025, 23% of China's population will be aged 60 or older. This policy isn't just about showing off shiny futuristic tech on the global stage. It's a calculated, urgent response to severe demographic pressures. They absolutely need these machines to support an aging society and keep national industrial production running as the workforce shrinks.
Which brings us to Section 3, the autonomy bottleneck and the challenge of reality.
We need to demystify some of the huge numbers you might be seeing in the headlines. Yes, it's true that 54% of global industrial robots went to China in 2024. But remember, that measures conventional automation, like robotic arms on an assembly line, not humanoids. And that massive 10,000-unit humanoid deployment capacity targeted for 2026, that is just a state policy goal. It's an ambition, not a verified reality of functioning robots walking the factory floor today.
This quote really hits the nail on the head. A curated martial arts demonstration on video does not equal economically useful autonomy. A viral clip shows you the one time the robot got it right after hours and hours of setup. But a factory customer, they don't care if a robot can do a backflip. They need a machine that can successfully pick up a part 10,000 times in a row without breaking down and without needing a human to constantly reset it.
To achieve that true factory-level autonomy, developers have to overcome some severe physical hurdles. First, they need the dexterity to grasp wildly varied objects. They need generalization, meaning if the factory lighting changes even slightly, the robot doesn't suddenly freeze up in confusion. They need absolute guaranteed safety around humans. And, very practically, they need batteries that last longer than a short PR stunt with repair costs that aren't going to bankrupt the factory.
So, how are they trying to solve this bottleneck? Well, China's policy is heavily focused on forcing a massive data production system into existence. Take the AgiBot training facility, for example. Robots there are being operated for up to 17 hours a day, performing incredibly mundane tasks, like folding shirts or opening doors. They aren't replacing workers yet, they're just grinding away to generate the massive amounts of high-quality, physical action data required to eventually train reliable embodied AI.
And finally, Section 4. Who wins the race in this global competition?
Right now, the outlook is completely split. The optimists out there believe China will simply repeat their EV and solar playbook, use aggressive state policy to rapidly scale supply chains, drastically lower prices, and export globally. But the skeptics? They argue that humanoids are incredibly complex, fragile solutions desperately searching for a problem. For most repetitive tasks, a conventional, specialized robotic arm bolted to the floor is already faster, cheaper, and way more reliable.
Furthermore, this isn't just a simple geopolitical binary of one country versus another. Building a humanoid relies on a highly complex, deeply interdependent global supply chain. The U.S. currently leads in foundational AI and advanced semiconductors, while the hardware side relies heavily on rare earth magnets from China. This intense interdependence matters to all of us because the cost and availability of these future machines that could eventually build everything from your next car to your household appliances, are highly vulnerable to things like tariffs and export controls.
Ultimately, no matter how much policy support is injected into the system or how much hype floods social media, the only metric that will decide the winner of this race is the unglamorous economic cost of dependable work. At the end of the day, it all comes down to the cost per successfully completed work task over thousands and thousands of hours of continuous operation.
So as we watch this fascinating sector evolve, driven by billions in state policy and some truly brilliant engineering, we really have to ask ourselves, are we genuinely witnessing the birth of the next essential piece of industrial equipment that's going to reshape global labor? Or will the harsh realities of physical autonomy keep these incredible machines forever trapped in the demonstration phase? Thank you so much for joining me on this explainer, and I'll see you next time.